such. Calculate the value of Kc. So it's similar in the way you set it up. Equilibrium, then plug in the values. Anything we're missing? So the one thing it's missing there is the PCl3. For that one, you can assume, I believe, the concentration of the Cl2 is equal to the PCl3 because it's a 1-to-1 ratio. So that's the only weird thing on that one, is it doesn't tell you the PCl3. I'm sorry, initial concentrations, pardon me. So on number 5, it's a little trickier because it's not all at equilibrium. PCl5 breaks up into PCl3 plus Cl2. It says the initial concentration of the PCl5 is 2 molar. The equilibrium concentration of the Cl2 is 0.3 molar. So this is a way of counting for the initial, the change, and the equilibrium. It spells out the word ice. It's a computer. It's not good. So you start out with 0 of this and 0 of this initially. You want to get 0.30, so you have to add 0.30 to this, and you also have to add 0.30 to that. So the equilibrium concentration would be 0.30 of this. In order to get 0.30 from that side, you have to subtract it from this one, so that's 1.7 molar. So these are our equilibrium concentrations. Once we have our equilibrium concentration, we can then plug it into our equilibrium expression, PCl5, and they're all to the first power, so our Cl2 is 0.3, our PCl3 is 0.3, and our PCl5 is 1.7. So 0.3 times 0.3 divided by 1.7 should give us the value of K for this particular problem of 0.05294. And that should be one of the options for number 5. Number 11 is the next one. Yes? Okay, so in this equation, we're starting out with all of this and 0 of those. So any of these that are made, it told us that this much Cl was made, so it has to come from the other side of the equation. So it has to come from the reactants. So if you get 0.3 moles of Cl2, the ratio is 1 of these is proportional to 1 of these. So if you need to add 0.3 from here, you have to subtract it from the reactants. Does that make sense? Kind of. The reason it's 0.3 lost here makes 0.3 and 0.3 here is PCl5 is composed of PCl3 and 2 Cls. This formula, these are equal to each other. When PCl5 breaks apart, it breaks up into 2 pieces, piece 1 and piece 2. If you have one PCl5, like one of these, it breaks up into Cl2 and PCl3. So it's a 1-to-1-to-1 mole ratio. That makes sense? So that's involving